Hey, come on in. We'll get started in just a minute or two.
Welcome, welcome. So how many of y'all is this your first SCaLE? I know this is your first SCaLE. Anybody else a first timer for SCaLE? Oh, awesome.
All right.
Awesome. Well, for those of you who are not first timers, you'll recognize our speaker, Ryan. How many SCaLEs have you been at?
I think I've been to 4 or 5. It's
Yeah.
been a couple times.
So Ryan's been presenting here for a while on all kinds of developer topics. He's from Sacramento, so pretty close by, closer than me. And today he's going to share with us how to use Backstage software templates for development. So welcome, Ryan.
All right, thank you. Thanks, everyone. I'm here to share Backstage software templates and some lessons learned that I've kind of picked up in the course of my interactions with Backstage. My name's Ryan Jarvinen. I'm from Red Hat, and so there's some Red Hat logos on my slides, but Backstage itself is a CNCF project. So hopefully the information in this session ought to be usable by anyone who's using Backstage, whether they got their Backstage from Red Hat or not. So I'll hopefully ask me any questions if it's not clear, but I'll try to reinforce that piece of information. So what I wanted to cover today first was kind of a little bit of motivation for why Backstage and a look at application complexity in a cloud-native world. And then take a quick look at what is Backstage. How many people already know about Backstage? Looks like most of you. Okay, I'll speed through that section. And then we'll get into Backstage software templates, or as they have previously been called, Golden Path templates. I think that name Golden Path templates is kind of falling out of fashion, but for historical reasons, I have it listed in here. And then within those software templates, we'll look at 3 specific areas. There's a set of inputs that we're going to investigate, some scaffolding that'll happen, and then we'll look at some outputs. And then I'll go into, we'll see if we have time for Q&A. I'll try to do a demo of some scaffolding if the demo environment holds up. So let's see if we see how lucky we are. So traditionally, if you were a software developer, you might start off building an app with something simple. Especially years ago, you'd start off with just a source code repo, or you'd grab an editor and a compiler, and you'd say, "Great, here's my source." You throw it over the wall to the other team, and off you go. Right? That's your release process. Is pretty simple. But over time, things have kind of evolved, right? Now developers may need to use something like containers. They may be using Podman or more likely maybe Docker. They're going to need a container registry to push that container image to. They're going to need a place to run containers, like a Kubernetes cluster or some sort. They're going to need a CD to deploy this. They're going to need a lot of YAML to capture all of these different abstractions they're adding in, and a place to store all the code and all the YAML. And don't forget to shift security left, or whatever else you're trying to shoehorn into this process. And pretty quickly you can get devs that are very overwhelmed by the CNCF landscape and all that's going on there as they try to conceptualize 1,000 different of these components and keep it all straight in their head. You run out of memory bandwidth, and what You know, if you bring them backstage and you say, oh, hey, how about just one more YAML, you know, they may already be at their limit, right? So, in fact, I found this kind of funny. I found this posted online. Sorry for the quality of the screenshot, but this was a sentiment from another conference. Someone posted this in a bathroom or something and was saying, you know, they give us these added weight, essentially, well, all I really need is FTP. You know, I just want to ship my files. This person clearly has got an oversimplified view of how to deal with technology these days. But, you know, you could definitely find folks that have a severe backlash to all the added YAML that they're having to absorb and keep track of. This is a study from Salesforce, Salesforce Productivity Survey. They said 76% of organizations say cognitive load is so high that it's a source of low productivity. So developer portals are designed to target this in a variety of different ways. It improves onboarding, coding time, build time, run time, variety of different optimizations, and hopefully is going to allow you to enable developer self-service via your platform and allow different tools and technologies to be glued together and offered in a way that's easy for developers to adopt without having to worry about what are the best practices, what are the security guidelines, how do I maintain or improve this thing over time. It's all going to be spelled out for them so they could kind of follow along with a golden path experience. So Backstage is I know you folks already know what Backstage is, but for the folks on video, I'll go real shortly into Backstage was started by Spotify. I asked someone at Spotify about how big their software catalog was at Backstage, and they said they had something like over 100,000 components in their software catalog. That's a very large organization with a very flat structure if they have all that visibility, right? And that may be what you want to achieve. You may also want to try to lock down Backstage into different kind of siloed experiences and add some RBAC or other kind of precautions in there as well. But started at Backstage, or started at Spotify as a way to help organize all of these hundreds of thousands of different web services that they were trying to maintain and manage. And people really had an issue with trying to find out what was running in production, how do they use it, how do they adopt it, is it safe to adopt? Anyway, their approach really resonated with a large number of folks in the industry, and there's been a good deal of adoption for Backstage. A lot of different companies jumping in and participating, either using it or participating in the ecosystem. Backstage is going to come with a centralized software catalog to keep track of all of your different services, websites, libraries, data pipelines, etc. Plugins are going to be a major part of Backstage. They're going to integrate with each of your different pieces of infrastructure and provide visibility to your users. We'll see examples of that a little bit later in the demo. Software templates are going to give you ways to quickly spin up new projects and standardize your tooling. And tech docs, easily create, maintain, and work on documents in a kind of docs as code style. Last thing we have is search. Then this is kind of my main selling points for Backstage. Is this list here. Search, having an integrated search system is pretty cool. This will, I think, as far as I know, indexes not just your source code, but also all the tech docs as well, making everything very easily discoverable for folks. So Red Hat also has its own version of Backstage, a kind of an enterprise version of Backstage known as Red Hat Developer Hub. There's a couple differences here. It has more, I guess one of the main differences is the way we manage plugins. With RHDH is kind of a dynamic plugin system. So you have little kind of dip switches or checkboxes. You could kind of flip a switch over and say, I'd like to install Tecton Pipelines plugin. You flip the switch, it installs in the background, and then it's up and running without you having to rebuild Backstage from source or rebuild a new container and deploy the container. And it's I don't know, I think the dynamic plugins is my major selling point that I list there. Let's see. So on to Backstage software templates. If you want to see the upstream documentation, this is your link to the upstream backstage.io/docs features software templates. That's where I go anytime I get really deep and need follow-up advice. That's your key to the upstream docs. You may or may not see the words Golden Path mentioned in those docs. That was a big part of how Spotify described templates historically. And so what is this Golden Path? They didn't ever really define it very clearly. They kind of mention Golden Paths in a bunch of different areas, but don't really give it a clear definition. So here's my attempt at trying to define these Golden Path or software templates. It's a self-service workflow, primarily. It's a means of reducing that cognitive load for developers and without abstracting away any context and underlying tools and technologies. And it allows people to get started with new projects while following best practices. So, template example number 1. Let me see, here is not the tab I was looking for. Or is it? This is the tab I was looking for. All right, so I have some experience with Backstage. Me and a couple coworkers actually put a book on Backstage together. And so the template examples I'm going to walk you through today are examples from that we put together in this book. The source code is available on GitHub. You could find it under the Developer Hub Books org. And so I'm going to go into this org and click on the RHDH Book 1 templates repo, and we'll look at this Quarkus with Angular template. So a couple things to notice about this template. There's the template YAML, but then right next to it, I also have another folder here. It's called Skeleton. This has a source code repo. And this other folder called Manifests, this has all the YAMLs for my Argo CD, my deployment YAML, all the different YAML manifests that Kubernetes is going to expect, and Tecton and Argo CD and my other services. This whole repo is basically going to get handed off to Argo CD to deliver the workloads. This whole repo is going to get added into GitLab, and this template is going to describe our process on how we do that. So you could see right up top here we have this viewable by everyone. We've got a API version, a kind. This is commonly referred to as a group version kind declaration, these first 2 lines here. And it may be familiar, this kind of format may be familiar to you if you've used OpenAPI spec in the past. This is what Kubernetes uses, so it looks like you might be able to stuff this template into a Kubernetes CRD or something. I have seen kind of experimental support for that, but it's not supported yet, adding these into Kubernetes, right? But you basically, this is the scaffold, this is the YAML that we're going to start with. You can see the name here is, or actually let's look at the title. We're going to look for something called Quarkus Service with Angular Front End. You can see there's some tags on here. And let's take a look at how this will look in Backstage. So this right here is my live instance of Red Hat Developer Hub, which is our Backstage. I'm going to click on Create to take a look at the templates that are available, and I'll look for that Quarkus with Angular front end that we saw in the right here. Quarkus service with hosted Angular front end. Got it. So I'll hit, you could see that that string of text matches up across there. I'll hit choose, and we will get into the first page of our template here. This is going to ask us to provide information about the GitLab location. If I scroll down a little bit, I could see that's the first in our spec. We have 4 different inputs here. The first input is going to be providing information about the GitLab location, like we said. So I'll just accept the defaults that we've loaded in. I'm going to use the development org. And for the owner, let's say I believe I'm user 8. This could also be owned by a team more appropriately. It may be your front-end dev team or your, I don't know, some particular product team that owns this rather than an individual user. But and I'm going to deploy this to the demo 8 namespace in Kubernetes. Next step on here is I'm going to provide some information about this new component. Oh, that's what I just went through. That was the demo 8 namespace that I added in. I did this owner selector and pulled out a user attribute. And then next one is providing build information. So let's get down to this build information. This one's going to accept a registry host and a tag. Looks like the default value is going to be latest. So let's see. Looks like we've got that. We could review all of these things that we would like to start off this new user with their getting started experience. And then here's the scaffolding process. First thing it's going to do is pull out, actually, we'll step through each of these. Let's see, step through each of these over here. So this is listed as the steps section. I wanted to point out each of these action steps. So the first action is to fetch a template. It's going to look at that skeleton folder and try to add in all of these different values that we just collected from the user and template them into the source code directory. Then we're going to use this publish GitLab action in order to publish that source to our GitLab repo. If you had GitHub instead, or if you were using GitHub instead, there's also a publish GitHub action. You can find that in the upstream documentation. But I'll just walk through quickly the different actions we have here. Next thing we're going to do is fetch a template, another template that's going to be used to template out those manifests for Argo CD. Here's the values that we're going to inject into Argo CD. That'll go to our GitOps tenant. And then we'll publish that to GitLab as well. Once that's published to GitLab, we'll end up with some new source code, right, that we can register into Backstage. So the source code repo should get registered, and we actually have two that get registered since there's a Quarkus and Angular component. And then the last step we do is this Argo CD create resources action, and that's going to ship everything to Argo. So that'll get us down to this output section, which has links. So let's see, these links right here were all introduced because I have defined them in the template. So if you want custom links for your developers at the end of a workflow, you can use, Like you could see here, I have the parameters, cluster ID is injected into the string here. There's a output from one of the steps injected into the URL here. So why don't I go through to the source code repository, and we can see what was published. So here's my new repo. This was just published 2 minutes ago, so just got scaffolded out for us. This was what was in that skeleton folder before, right? And cataloginfo.yaml is one of the main files that this is what gets registered back to Backstage. And this also has that open API spec, kind of group versioning kind up top. The kind is a component, and you could see in here, here's the links that we had in the template that now have the actual cluster ID injected into the string. So the templating actually worked, or the scaffolding actually worked, right? Here's the value injected in. And we can go, here's a link right to the source code, or we could also open up the components either directly there or from the software catalog. So here's the Quarkus component. Each of these tabs is generally powered by one of the Backstage plugins that we have. So I mentioned there's a plugin for Tecton. That's going to be underneath this CI tab. So if I click on the CI tab, I could see we have a pipeline run that's in progress here. I could go to the CD tab, and this is data from Argo CD. I don't have to provide any login to Argo CD or any special access. My developer can go in, scaffold out their repo, and immediately get to work and automatically have Argo set up. If they need to check the status, they go right here to Backstage. They could see everything that's happening with their pipeline, their deployments. This is Kubernetes tab is provided by the Kubernetes plugin. This particular component also has an API, and so if I scroll down a little farther in this catalog YAML, or catalog info, you could see we introduced a separator and then this API. So this also has a API that's discoverable and findable via this API tab as well. And this basically gives you like an open API spec interaction with the component. So I could go in here and I can try out a web request and see what the response is. So pretty cool basic inspection. I can see how this particular component links up to other components and other relationships within Backstage. Let's see. Any other questions about this particular part here? About these different tabs? No? This is the basics of Backstage. If you've already seen Backstage, you're probably already familiar with this piece of the puzzle. So I'll get back to, let's get back to my slides, and I'll see what's next here. So we looked at the Quarkus with Angular repo. We looked at the group version in kind, the metadata, and the spec. We stepped through the parameters, the action steps, and the output. And we took a look at the repos, the catalog info, YAML, and the links area. I took a look, yeah, we already ran this. And we ran through these template action steps. Okay, so the result here is 2 repos, an Argo CD service that's been installed and deployed, Tecton pipelines. We should have the OCI registry up there, OCI logo or something. But yeah, and then we're deploying this on Kubernetes. So that's the whole kind of software delivery pipeline that we've established. Let's skip through. Here's kind of a typical developer workflow that's basically been achieved through 2 or 3 clicks and a lot of YAML work, but you know, depending on your scale, if you have enough developers, enough services, onboarding developers, junior developers in this way can be massive. Okay, any questions about, oh, this is more slides than I was thinking. Okay, all right, so any questions about that first part? No? All right, I'll move on to the next step. What happens after you create this template and now something evolves, right? That always happens. You always need to maintain now that you've created it, now you're cursed with owning it and maintaining it. That's the sad reality. So let's take a little bit of a look further down the golden path to see if it still looks golden, or if we can maintain its glow in some way. So we'll take a look at this Quarkus application patch template. This is going to be a patch template. Let me see if I can demo this part. I'll go back to the create workflow. I'll pick the Quarkus patch template. And then for the GitLab, let's see, GitLab, what was my repo name? It was this thing. Let's copy this. Okay, and it's in the development org with this repo. It's going to use that as the branch name. This is going to patch a POM XML. It's going to provide a updated version of Quarkus, which is our Java run environment. And it's going to patch the Docker file to have an updated version of OpenJDK. So 2 major Java upgrades that we're going to implement. So I'll hit review. We'll hit create. And then I'll jump back and we'll kind of step through the actions that this one has. Let's go to custom component patch, Quarkus app patch. So this one is going to have, I actually have these steps, I think, in the slides as well, so maybe I'll just step through the slides. But yeah, this is going to fetch the repo, patch the repo, open a merge request or pull request, depending on if you're writing for GitLab or GitHub, and then link to that merge request. So let's go back to our catalog. Let's find that demo 8 map service. And now if I go to issues, we don't have any issues, but if I go to pull requests, now I have a new pull request in here that was from the template run that we just did. And if I take a look at this one, we could see there's some changes, and it looks like that did update our OpenJDK version and our Quarkus version, and make a small change to our POM XML here to include Quarkus small RAI health. Okay, cool. Where's the merge button? Overview. Merge. Let's merge this. And then go back and see what happened in our demo. All right. So now if I go back to this, I could see this merge request is now changed to a different color here. And whoops. If I go to the CI tab, I could see there's a new pipeline run that's kicked off. It looks like our last one failed. We could sacrifice that one to the demo gods. And there we go. Any questions about that part there? Yeah. You tell it what, yeah, so the question was basically, this seems brittle, like we're patching something very specific in a file, but what if the developer changed it first? Is that kind of what you were implying? Yeah. I think with this type of workflow, you'd kind of want to identify, hopefully, who's responsible for the Docker file and who's, you could say, hey, everything in that manifest repo, that's the platform engineering team helps manage, or you go to them to merge your pull request. They at least review changes in the manifest repo or something like that, or in the Docker file. So you could try to have some kind of policy or organizational enforcement. There's also support for more advanced orchestration and review of code changes that's coming into Backstage. This what we're looking at today is called the scaffolder, but there's an alternate system that's an orchestrator that has a little bit more capabilities to check first and look for sign-offs and reviews and things like that. So yeah, I would say this is kind of a brittle, let's take a look at the code for this one. This is not the right repo. Let's take a look. Where can I find that code? Okay, here's our patch template. Here is the particular action that we're using to do the replace. This is a plugin from Roadie HQ. So I think you get this when you install the Argo CD plugin from Roadie. It doesn't just install the back-end plugin and front-end plugin, but I believe also provides some scaffolding capabilities as part of that plugin functionality. And so this is just doing a very, very basic FS replace. It's very hacky. It's going to find a very small string. It should probably be adding some context on either side of this, This one's probably okay to search on because it looks pretty unique. But yeah, this kind of, we put a big warning in here because we were like, yeah, this is a little bit brittle. You could see this. Am I going to need another patch template to update my templates over time? That's basically the direction we went in the book. Was we had 2 patch templates. One to update the application code, and another patch template to update all the templates to make sure anyone who came along later down that golden path didn't have to run both templates, that they just got the newer, the newer source. So that's mostly what I wanted to demo for that piece. That covered fetching, using that Roadie HQ utils replace call, and then publish GitLab merge request. These are the action steps that you could try to look up in the official docs. Yeah, I said this part was messy. Publish the merge request, and then we found out that there we go. All right, so in summary, to basically capture what we've seen so far, all this YAML can be a little bit overwhelming, especially for new developers. You can rein it in with, and if you tell them only one more YAML, they're probably going to know you're probably lying to them. This has just one more YAML for the template, but then we used a second template, and we, it introduced a lot of YAML behind the scenes. But it was a lot of YAML that our developers didn't have to deal with, right? So hopefully Backstage is like your golden path experience to onboarding developers into the CNCF landscape, and to give them access to all of this good stuff without drowning them in all the details. That's the main idea. So Backstage plugins are going to help provide that real-time view of your application infrastructure, health and security. Backstage helps answer two very important questions. What am I running and how do I use it? Software templates are going to provide best practices with GitOps and automation, self-service with guardrails for cloud-native dev, and YAML for platform engineers that helps simplify software delivery for your mainline developers. If you want a lot more examples of more than just what I have from the slides here, we actually have a software templates library. This is available on GitHub. You could search, well, I put a short link here because it's a long URL. So here's the short link, but this will go to a repo we have that has a lot of examples on different template use cases that you might want to use. These aren't always the easiest things to share because usually templates can have a lot of configuration details embedded in the template. So usually I store my templates in a private repo or in GitLab or somewhere secure because it's going to have configuration, host names, things in there that I generally encourage developers not to put in their source code at all. But Backstage, that's the way things are done today, is a certain amount of configuration is going to go into these templates. So they're not the easiest things to share, but here's a lot of great starting points that you could use to kind of build from. Lastly, if you want a copy of this book, if you'd like to read through it, I only have one copy with me here today, but you could get an ebook copy that kind of tells the story of all of what we learned building out that experience. And yeah, definitely give me your feedback and let me know if you would like to see like a live workshop version of this. I have this set up as an interactive workshop you can go through as well. So send me an email if you'd like to see the interactive version deployed somewhere. That's it for me. Any questions? Yeah.
We're just starting to get going with Backstage. We basically just have our initial image built, starting on our first software templates, getting a few of the backend plugins installed, things like that. A thing that we are targeting, one of the targets of Backstage for us is a mechanism to create and maintain or manage like ephemeral environments that are sort of medium length lived, like on the order of a few days, something like that. We have a custom in-house thing that we made, and now we're trying to retire that and replace it with Backstage. And from the things that you've shown, I think I have a good understanding of how to do like the sort of create and update, like through patch sort of scenarios. I was curious about the destruction side, how you might go about doing that. I have been conceptualizing in my head as maybe a separate workflow that is able to like enumerate the catalog info items of things that had previously been deployed that way, so that you could sort of pick one from the list and say, yeah, that's the one I want to get rid of. Is that reasonable, or is there a better approach?
Yeah, there's good question. I think maintaining the content in the catalog is definitely an evolving challenge. I think there's some folks use importer tools to try to bring in a lot of their kind of like import existing catalog content from something else and bring it in. So I know there's mechanisms where you might be able to like periodically sync or re-import or do something to kind of maintain your catalog in that way. But also, each of these catalog entities, you register with Backstage, they get stored in a database, and there's also a background process that watches GitLab. And so even if you unregister it from Backstage, sometimes the background process can look and be like, oh, I've discovered a new cataloginfo.yaml. Let me re-register this for you. And I'll have things that I'll like delete out of the catalog that will suddenly reappear because it's using this kind of GitOps, like whatever's in Git is the source of truth. And so in some ways you want to not just unregister, but delete the Git representation of it and also unregister it. And you could do that in a couple different ways. You could have a template that does something like that, theoretically. Yeah, there's a couple different ways to do that. But that's a challenging, maintaining the catalog's definitely an ongoing challenge.
Thank you.
Yeah.
Okay, more.
As we're getting started with our software templates, we're noticing that based on input from developers, we need to follow a different branch, ask for different questions, or we'll have different defaults depending on what they've selected in a previous step. So far, our experience says that you can't change further inputs in a service template based on the output from an
Oh,
input?
yeah. So you're asking, like, can you use an input from page 1 as a value on page 4 or
Right.
2 or 3 or something? Yeah,
Yeah.
as far as I know, that is not supported currently, and it's a major pain point for me as well. I want to reuse some of the values instead of having to try to chain multiple things to. Yeah, it's frustrating. I would take a look at see if the orchestrator has any advantages over the older scaffolder,
Okay.
because I know that's going to have more functionality in the future.
One of the things I was thinking of is if you could chain the two templates together and have the first one output a YAML file, intermediate step, and then the next one load that YAML file. And
Yeah,
that
yeah.
doesn't seem like a possibility yet either, but I'll look
You could
into orchestrator.
definitely have the first one probably add like labels or tags or something or annotations, and then read those annotations and try to make sense of them and use them in a particular way. Yeah.
It's trying to get the developer into that workflow without having to go back and select another.
Yeah, yeah. In my experience, that's definitely a pain point for me as well with templates, not being able to recycle those values. And I know that's something that gets brought up upstream frequently.
Okay.
So I don't have a great solution for that other than just add more variability in the template. I get, like you were saying, like they may not be looking for the main branch or the master branch, that there may be some other, like you can have an input that defaults to master or main but allows them to fill in their branch name.
Right.
And then you get a little bit more flexibility, but then yeah, you want to reuse whatever that value is. Yeah. And you could use it during the scaffolding and output, but not as part of the input processing. Yeah.
More questions?
What are some good community resources? Like if I wanted to discuss strategies and stuff like that with people that are using Backstage, is there like an official?
There's I think they have a good, there's like a Slack, CNCF Slack for Backstage that's decent. They're pretty active in their chat system, and their documentation is not super rich, but there's a lot there to look at to get started with, I think. So those would be my main two. Their kind of community forum or chat and the docs.
Okay, thank you.
Any more questions? Okay, well, thank you very much, Ryan.
Hey, thank you.
And you all are free for lunch, but don't forget there's one more session after lunch in this track. It's actually on automating ephemeral environments, so you should probably stay for that one. We'll see you all then.
Test, test.
Then I just turn it off to pause. Push it again. Test, test. Sorry about that.
You seem to be all set.
Yeah.
pronounce your name for me?
Sure. Thank you.
Hey, folks. Sounds like people have been having a good SCaLE. You've been having a good SCaLE? You ready for the last talk of SCaLE? Yeah, okay. Yeah, have a good time. Vahan's going to explain to us about how they create their ephemeral environments at GoodRx, and you can too. So thanks so much for being with us for yet another SCaLE Cloud Native track. We try to bring you lots of great speakers who have lots of great techniques and information to share. And I've been very impressed with the caliber of speaker and the amount of knowledge we've had this year. And am happy to have a strong finish for the track. So with that, why don't you take it away?
Thank you so much. Welcome, everyone. Well, thank you. Thanks for the intro, and let's go ahead and jump right into it. So we're going to talk about how we create live ephemeral environments at GoodRx off of pull request, and how we automated in those environments. So a little bit about me. My name is Vahan Malikian. I'm an engineering manager at GoodRx, working in the DevTools team, building tools for our developers. And this talk is about one of those tools that we have at GoodRx. So a little bit about the agenda and what we're going to cover. In the beginning, we're going to do some introduction and set some context in terms of what is the problem and what we're trying to solve with these automated ephemeral environments. And then we're going to dive right into it and see lifecycle in action. And then majority of this talk is probably going to be demo, so over 20 minutes. And then we're going to talk about our future plans and hopefully have some time left for some questions and answers. So with that, let's go ahead and get started. So yeah, I'm going to talk about microservices. This is something that most people know about. They have risen in popularity because they offer scalability and flexibility. The core promise for microservices was to enable independent deployments, technology diversity, and also resilience. But it comes at a cost. So there's a lot of trade-offs to gain these benefits. And in this talk, I'm specifically going to talk about the trade-offs on the technology side. There are a lot of trade-offs on the organizational side as well, so we're not going to focus on those today. So let's see. So some of the challenges that we have with building, testing, and iterating on microservices is environment parity. Replicating production infrastructure is not easy, and especially in an automated fashion. So people mainly rely around kind of like traditional environments where you have your pre-prod, staging, dev, QA that are always on, and changes get pushed up to that chain, tested, verified, and then ultimately released. Microservices can have a lot of interdependencies, upstream and downstream. Those can be challenging in keeping healthy, especially when you have multiple teams or products competing for those static environments to verify their changes. It can create bottlenecks, specifically around end-to-end testing. And of course, there are also data consistency challenges as well. What data is this specific microservice serving on? Is it impacting others if they're testing? So yeah, these are essentially the problems that the tool that we built is trying to address. The name of the tool is Lifecycle. It's a pretty overloaded term, I know, but we understand that, but it is the name as of now. So before we get into the ephemeral environments, let's kind of like set the standard, like what we mean when we say ephemeral environments, specifically in this talk's context. So essentially what we mean is that the lifespan of this environment is short, most times tied to a pull request. So as long as your pull request is live, that environment lives. When you merge your changes or you close the branch, that environment gets cleaned up and the resources freed up. And we also mean these environments to be connected. So they are fully connected with their upstream and downstream dependencies. So they're essentially full end-to-end environment of overall services. And also they're isolated, where you can only work on the dependencies that you care about. There are a lot of sub-dependencies that you might not really care about, but you might be working on multiple different components that you want to see how they interact with each other once fully deployed in an end-to-end environment. So this is what we mean when we say ephemeral environments. And ephemeral environments are not always the right answer. So it sometimes is the best path forward, sometimes it is not. And this is kind of like, I call it the environment scalability matrix, essentially. It depends where you fall within these quadrants. You might consider or not consider ephemeral environments because they come with operational cost and other things that we will get into shortly. So if you have a small number of services and a small number of development teams, maybe traditional environments, the static, staging, dev, QA might be a better solution. Or if you are dealing with monoliths, that's another part where maybe like a static environment is the better option. Or you're on VMs, like all of our ephemeral environments are in containerized Kubernetes environment. And for ephemeral, if you want to only deploy the things that you care about, like I mentioned, you might only care about a backend API that you're working on. You don't care about the front end and 10 other dependencies that it has. You just want to test that with some curl commands or postman or whatever. So ephemeral environments are right when you're in microservices architecture. You're using containers, and you have somewhat of a complex system which generally come with microservices architecture. And if you look at the matrix on the right, you can see that the cost of a static environment in a traditional infrastructure, static infrastructure, starts pretty low because you might have just one infrastructure. In contrast, the ephemeral starts with a little bit high because you're running this tool or the infrastructure to support this. But as the number of environments grow, traditional environments become big problem, like for operational, maintenance, correctness, and a lot of other reasons. Provisioning these environments becomes challenging. So, but with ephemeral environments, it almost kind of like just becomes linear. It doesn't matter whether you have 10 or 100 environments. It's the same infrastructure that is supporting it. You might need more compute resources to run these services, but operational cost does not increase. And how we kind of like calculated this is essentially with the complexity score, which is the number of services plus number of environments times some weight. And this weight essentially means what is the cost for the organization to bring up a static environment, like staging? How much is it going to cost, both development time and also the number of environments that you're going to have to bring up in addition to operating these environments after they're up. So yeah, essentially now we're going to talk about the exciting things. What is Lifecycle? So essentially, Lifecycle is a tool that GoodRx built starting around 2019. As we were moving to more microservices architecture, we had a monolith in the earlier days, but we were trying to break it down because the company was growing, the engineering team was growing, and we wanted to give some autonomy to teams and so that they can deploy or release features faster. So Lifecycle is essentially the orchestrator between GitHub pull requests and our infrastructure. It leverages our existing CI to both build and deploy. It does not natively do the builds and deploys, and this was I guess, a specific design decision made so that our ephemeral environments are the same as we go to production or as we have in our static environment. We still have staging environment, but for other use cases. So Lifecycle orchestrates with CI and deploys these services. It figures out what needs to be deployed. It knows how to connect this environment together, and you'll have a fully functional environment up and running once that process is finished in a isolated fashion. So a little bit more about Lifecycle. You configure Lifecycle with a YAML configuration. Yes, another YAML, I guess, that needs to be managed, but this essentially describes the environment and what are its components, essentially. What are the required components and what are the optional components of these environments? And we will see in detail, and we'll kind of like go over this configuration during the demo, so don't try too hard to kind of like understand what's going on there. We'll cover that. A simple workflow in Lifecycle looks like somebody opens a pull request, we queue the environment creation. There are two different ways an environment gets deployed. It's either automatically for each pull request, or we'll just keep it in pending state, and when users add the Lifecycle deploy label, only then we deploy it. And environment gets deployed and created, and when the branch is merged or the PR is closed, the environments get destroyed, resources get released back. All right, so let's get to the exciting part. But before we start the demo, I kind of like want to give a high-level flow. It's going to be a long demo, and I want to make sure we have we're on the common ground. So what we're going to do, we're going to create a PR in a demo repo, which is going to create the environment, which we're going to interact with the deployed application. And we're also going to talk about a static environment that is managed by Lifecycle. And I've called it static SCaLE, so that it's kind of like, because we're at SCaLE. So anytime we look at static SCaLE or I mention static environment, this is not the traditional staging production type static environments. This is a static environment managed by Lifecycle, which is used as the default dependencies for other pull request based environments to be used if you don't care about those dependencies. And then we'll also add a optional dependency to one of our environments so that it can create its own one, and then we can play with it. All right, so let me do that. We'll need to mirror. Okay. So I got 3 tabs open, and we're going to go kind of like one by one. I hope you guys can see the text. So first, let's create a pull request in this tutorial front-end repo. So to do that, I'm just going to edit the README file, and I'll do all this through the GitHub UI. Let's call it demo. I'll create a pull request. Let it create on this default branch. We can call this SCaLE demo. And I'll click create pull request. So if everything works, we should get a lifecycle comment block added. There we go. I have lifecycle running locally right now on my machine, so all of this stuff is local, but in a deployed environment, everything is the same. So as you can see, we got this comment block added to the pull request. And it already started building. We will see why this happened shortly once we look at the lifecycle YAML configuration file. And there are some interesting things I want to talk about in this comment. And we're going to kind of like look at this or other environment comments pretty frequently during this demo. This essentially is the mission control of the environment. You can see we have tutorial front end. This is the service name. This is the branch that is building off of, which is a default service. So anytime ephemeral environment gets created for this repository, it will have tutorial front end by default. It will build and deploy tutorial front end. It also has some optional services. You can see the tutorial backend and then a database, which is a backend dependency, but they are not checked. So essentially, we're using lifecycle own static environment as the dependency for this. But we can check this checkbox and it will create our own. We will do that during this demo. And we got a unique ID for our environment, purple block. You never know what you get with these names. Sometimes they can be very funny. And there are other things you can do in this comment. For example, for your specific environment, if you want to expose or add some environment variable, you can do that right in this comment. So essentially, we're kind of like pushing the limits of a pull request comment. So we made a UI out of it. We do have a UI for lifecycle as well, which we will see. And as this is building, let's go back and look at the configuration. So how is it being configured? So there's this lifecycle YAML. And yeah, so this is the whole configuration. Let me make it a little bigger. And there are two main sections in this configuration. Number one is this environment block, and then the services. So first, let's talk about the environment block. This is what sets up the default and optional services. This is also what sets up the auto deploy. And we saw auto deploy in action. I just opened the pull request. It automatically kicked off the deployment. And also, this is where we set up the optional and default dependencies for this specific environment. As you can see, the tutorial front end, which is further defined in the services block, is a default service for this environment. And tutorial backend, which is defined in a different repository, is an optional service. I'll just go over this very quickly. We have documentation about this. And there's a lot of other things that is not listed here. But essentially, we're defining a Helm deployed service. So we call it the type of service. What type of service are we deploying? There can be different types, like Docker type, if you just want to deploy a public Docker image for databases or any other dependencies. So there are different types. We specify the repository for the service, which is the repository that I'm in right now. We specify the default branch. So if other repositories try to build this service, which branch should they use as default? They can always specify their own, but we need to have a default branch specified. And then we set some Helm chart configurations, like the chart name, value files. We can also inline set actual values in addition to value files. And we define the container, essentially. What are we going to build and deploy? So we have a Docker file. Let's see, the Docker file is referencing this Docker file at the root of my repository. It's going to expose this port. And this app essentially is just a straightforward Next.js app. So that's all it is. We'll see that once it's deployed. And then we have the environment block. This is the interesting part. This is where we set environment variables, both build time and runtime variables for the container. And you can see that like this pattern is essentially environment template variables. So these are things that we don't know at the time of building. We will know at runtime. So for example, for our app, which is a to-do list app, I guess we just add items and then we'd mark them as done. We set the API URL to be the tutorial backend's public URL. Now, which backend is it going to be? It depends on the configuration. If I don't set or don't enable it, it's going to be the default static one. So lifecycle in runtime will replace that with the base URL of the backend deployed in static environment. If I check that, then it's going to replace with its own version of the backend, which again we will see shortly. And then this is just build UUID. This essentially is that, I think it was purple block, is that name if we need to use it for some reasons, and you will see how, how we're going to use that here. All right, so let's go back to our pull requests and see if our environment seems to be deployed. So let's check it out. I'll scroll further down. You can see now we have this deployments section which will tell us which service it deployed, which branch it used to build and deploy that, and we'll get a link. So let's open this link. And here is our app. This is something that I put before the demo so that it's easier for us to understand which environment we're in, because we're going to look at this same app deployed in multiple different environments, this ephemeral one and then the static one. And essentially, this is a to-do list app. I can, for example, say view tasks. I can add tasks. I can mark tasks as done. And yeah, for example, let's say new task. Just add it, and the new task is going to come here, and then I can just check it. It'll go away. If I look at variables, you can see that the API URL, which we set in our lifecycle YAML configuration, is pointing to this environment, essentially static SCaLE. So what is this environment? It's interesting, kind of like the approach that we took. This is an environment that is also a pull request itself. So an environment's life is connected to a pull request. So as long as we have an open pull request, the environment is going to be there. So we created a repository. We called it, let's say, static environment, and we create a pull request there with the static environments. And let's see what the lifecycle YAML for a static environment looks like. You can see it's much more straightforward. There are no services defined here. We just reference the services that we want to be part of the static environment. For example, we have tutorial front end, we have the back end, and you can have hundreds of services here. We actually do in GoodRx. So let's look at that pull request. Again, you see the same comment. And this time, you can see the UUID is static SCaLE. This is something that you can manually update. You can change whatever name you want it. You can get that name for you. And there are 3 services that are deployed. Well, one is a dependency for the backend, but there are still components that we deploy and manage. If I scroll down, you can see this additional checkbox that did not exist on our pull request-based environment. So essentially, this says that anytime there is a change on the upstream branch, rebuild and redeploy that service so that they always stay up to date with the latest changes on their upstream default branches. So if I merge something in the front-end code base, the static environment will automatically pull that change and build and deploy the new code. And here you will see that environment, the static SCaLE environment that we're referencing in our purple block for API URL. So it is this backend that we're using there. And let's open the UI for this. Let's go back. Let me just turn this shield off real quick. And let's do this. I'll put them side by side so that it's easier to visualize them. Again, if I go to variables on the static environments, it's the same. So essentially, the backend for this UI is the same backend. So how can we check that? Let's go to tasks. So I'll add one task here, something. It's been added here. I'll refresh the page. It's also here. Same, something else. And it's here. So we confirm that it's using the same backend. The same way, if I complete some tasks here, refresh this, that's gone. Complete task here, refresh this, it's gone. But what if I want to have my own backend? Let's say my change also requires API change. I added a new endpoint and I want to test it before I merge it. So let's go back to this is the purple block. So this is the pull request we created during this demo. And what I'm going to do, I'm just going to check this checkbox. And you'll see that it automatically also checked the database because it is configured as a hard dependency for the backend service. Database is needed. It's not an option. You have to have that if you want the tutorial backend. And it started building and redeploying. And let's look at it in our lifecycle UI. What does it look like? So this is the UI where you can see the environments or services that are being created. I don't know, is the dark mode or light mode better? Better? Okay. So yeah, essentially you see that the environments are being built. The information is coming from the same source for both the PR comment and the UI. There are environment details here, what this environment is, repository, branch name, et cetera, a lot of metadata is available here. And it's going to build it. While it's building, I wanted to show you guys something that we think is pretty cool. So sometimes it's difficult to know like which UI you're looking at. Like in our actual app, we don't have this like right next to our logo. So I mean, you can get that from the URL, but that also can be tricky because we use Fastly in front of the URL, so you don't know what is the actual front end behind that URL. It can be coming from a static environment, or it can be coming from your pull request environment. So we created this feature called envlens. Essentially, if I press Command 0, I'll get this block right in the UI, which will show me the same metadata that I saw in the UI. And this, the way this gets created, this doesn't require any client-side code change. This is something that we inject on the ingress level, and we think it's pretty cool. It helps our developers to know what SHA they are on, what branch it is, etc. And it has the build logs. Essentially, this is the container build logs using our CI. And another cool thing that you can do here is you can tail the container logs. So this is coming from the container that is running this app. So for example, I can open the same thing here actually, if I want, but for this purpose, so let's say on the SCaLE static side, which is using the same backend as the purple block, let's say I just add a task, new task. Probably already changed the backend here. Let's open the logs here as well. And let's refresh this. Okay, let's mark this task. And you can see the task has been complete. I think the backend already changed. But essentially, you can add tasks here. Test task. You can see the container logs being streamed right away. You can mark them. They're live logs. Now, these are not the same as console logs. These are server-side logs. So these are not client-side logs. And our developers, front-end developers, don't want to be hopping on into different clusters or doing other things to just see what their container logs are saying. So this is an easy way for them to see this. And they can also see the logs in Lifecycle UI in addition to this. And then I just do Command 0, it goes away, and then I'm back at what I was doing. So let's see where we are with this. Okay, so this is deploying. So actually, it was interesting what happened there. But yeah, essentially, it changed the backend URL. That's why I was not able to see them in the static environment. We have some other interesting things in the UI that maybe I can show while we're waiting for this to be deployed. For example, we generate this graph with the dependency so that we know this, for example, this backend depends on the database and is also consumed by the front end. So, and this is a simple environment. Imagine like for large microservices environments, this can look pretty frightening. And then you can search for your services here and kind of like understand how your whole galaxy of services interact with each other. And this gets generated for each environment separately. If I go back and uncheck the backend, this is just going to be this specific one, and it's going to show me that it's connected to the static env backend. So let's go back to the builds. Let's see if we're deployed. So let's open our tutorial front end again. And if I say view tasks, you can see that there were some additional tasks that were added here that were not there before. This is because it created a brand new backend, and we have like a seed script in database that generates some tasks for us. So it is a different environment. And if I look at the environment variables here, you can see that now this is connected to purple block backend instead of the static env. Okay. And let's quickly take a look at the tutorial backend repository as well. So this is the backend and what we're interested here. And it actually works the exact same way. So let's just open a pull request, but we're not going to do anything here. Say SCaLE demo. I'll just have it trigger the run, but then we won't wait for it to finish. And this is interesting. This service is set up to not auto-deploy. So let's see how that works. So I will get the lifecycle comment, and you can see it's in pending state. So it's going to stay in pending state indefinitely. You might wonder, why would we want to always deploy? Why not have it pending for all of them? Sometimes pull requests have checks, like PR checks, that run end-to-end tests. So for those situations, we want to auto-deploy them, so when the person that made the change comes back to their PR, they have all the GitHub checks already verified, validated. If it failed, they'll go check out the logs and debug it. And if they didn't fail, then they can just merge them. So how do this gets deployed? So again, I'm refreshing the page. It's still in pending state. I'll just add a label called lifecycle deploy. Right, label added, and this should change into building. Right, so it's building the environment. And again, I can click on the lifecycle UI. I will go to the UI of this specific environment, and this is called Autumn Cell. And you can see there's only 2 services here. So let's close this out, and let's go back to the lifecycle YAML for backend service. Okay, you can see, again, the same high-level 2 blocks, environment and services. And in environments, we don't have any optional services. It's only the tutorial backend. And how does tutorial backend know that it needs a database? It's defined in this. So this requires block is a place to specify hard dependencies. This is different than the optional services. Optional services are that, just optional. You can either use another one, or you can use, you deploy your own. But for requires, each one will need its own. And again, the rest is kind of like similar. We have the Helm configuration, the container build configuration, and we have another service here that we're configuring, the database. And we're using a database Docker file, and we're setting some environment variables for username, database, and password, and etc. And then it ends up building and deploying that environment. All right. Let me see. Yeah. Any questions so far? We're going to have a dedicated Q&A, but if there's any quick questions, yes? Yes, that's a very good question. So the question is, when you close the pull request, does it automatically clean up the environment? So let's test it. I actually forgot to show that. So thank you so much for pointing that out. So let's go back to our tutorial front end. So this is the pull request that we created, and we have our own environment. So let's open the environment here. So the environment loads, right? Everything is fine. I can just do whatever. Let's close this environment, or close this PR. So I'll close this pull request. Looking at the comment block, you can see that it went back to pending. Now let's try to refresh this page. It's gone. So all of the compute and everything has been released, and they're available to host other things. Thank you. I knew I was forgetting something, so. Okay, so now we're going to go back to our slides and talk about some interesting stats. And before we do that, let me kind of like do the presenter setup again. All right. All right, there we go. Great. So, yeah, let's go to some of the use cases. These are specific GoodRx examples, like what are some use cases we found for these environments. So development, right, the obvious one, you can use this for development, create your own ephemeral environment, do some prototyping, testing, or whatever. The next one is testing. It's very valuable for testing. We have offshore testing team, which are on different time zones, and developers just can add the environment URL in the tickets that needs to be tested, and they will just open it up and do the testing. Design reviews is another very good use case. Developers can send their updated version of the components or the page to the designers. They can review it on their own. There's no static environments involved, so nobody's trying to fight for resources. Oh, I'm using this environment for a couple of days or whatever, so everybody gets their own environment. Hackathon and experiments. We found this very useful in hackathons that we organize in GoodRx. It kind of like removes the whole problem of figuring out how we're going to deploy environments for our hackathons, because they're just a couple of days and there's a bunch of experiments. So we use Lifecycle for that. People just go and create pull requests, they get environments, they do the necessary code changes, and they present their development. Another one is external sandboxes. So we, for example, for partners and vendors, sometimes they need to integrate with our systems. And instead of just giving them the full staging or full pre-prod or some other environment, we can give them an ephemeral environment with the specific things that we want them to be working with. And last but not least, proof of concept. Again, is similar to development, so you can have your long-lived proof of concept, get all the buy-ins from all the stakeholders that you ever need to, and show them the thing actually deployed and working instead of just an idea. So let's see some stats. This is some interesting numbers here, so I want to take a moment to kind of like talk about each here. At GoodRx, Lifecycle manages over 120 microservices, okay? We have, on average, 160 plus active environments, ephemeral environments. We have multiple static environments that is also managed by Lifecycle. We have over 220 environments created weekly. So that's what, like 40 a day, 40, 50 a day? These are average numbers. The cluster that Lifecycle runs and deploys these environments has over 40 nodes. Nodes are 16 CPU and I think 64 gigabyte memory nodes, so they are not small nodes. Another interesting metric is the average environment density. So what we mean by that, each ephemeral environment that we build, how many components are within them? They're all connected to the defaults, but on average, they have 4 components. So it can be like a front end, or a backend, a database, a cache, Redis cache, or whatever. So the average density of the environments is 4. And we have massive cost reductions compared to if we had to create all of these environments statically. It would be a lot, both in terms of cost and operational overhead that we would have to deal with. So having said that, we plan to open source this. So when, we don't know, we can't really commit to dates, but we want to kind of like talk about why we decided that. So first, we wanted to give back to the developer community. We all, I think, benefited tremendously from open source software, both for learning and professional. Second is the demand. So people that used to work at GoodRx, they want this. They used it. They know what it offers, and they want to use it. And we want to share. So yeah, that's demand. And third is enhance. Like we want to improve, enhance this tool with the community, that people that use it and are passionate about it. Maybe there will be some use cases that we didn't even think about, or some use cases that is not really needed at GoodRx. Yeah, and of course, finally, we can expand it. Like I said, most of the use cases that are valid today for lifecycle, they were not even considered at inception. Yeah, so having said that, let's get in touch. So yeah, we're going to get to Q&A. We have a placeholder repository where we want you guys to hear from you guys. We can do discussions there or ask questions, answer questions. Just let's talk about this. All right, question. Microphone, please. Josh, Mike. Yeah, thank you.
So thanks for the demo. This is pretty cool. Like obviously, as you talked about your use cases, right? Like it's centered around interactivity, right? Like for automated integration tests, you don't need that. But as you said, like, right, you got some QA pipelines, design reviews, and those kind of stuff, which makes sense. Is there like a version of this that you have internally that is not centered around the PR workflow, right? So if I'm a developer, I might want to just like work locally, still be able to launch a bunch of environments, hackathon, whatever. It's not necessarily PR, right? It might become a PR eventually, but so do you have the different version of this as well?
That's a great question. We actually had some work done around that. So the short answer is no, but we can. So essentially, we can build a CLI for this, and then instead of being driven from GitHub webhooks, webhook events, you can just create via the API for this tool. We had an interesting project that was going on called, we called it Lifecycle CLI, which was centered around closing in the inner loop, essentially allowing you a way to sync your changes over to the deployed ephemeral environment and back and forth. So we kind of like put that project on hold for the time being, but there definitely is demand from within our company as well. Like there are problems in the inner loop, so we definitely can extend it. It worked at the time when the person that was working on it, Andrew Waller, he demoed it multiple times, and we hope we can revisit that and kind of like just restart that initiative. But that's definitely a valid use case where there are times you don't want it to be tied to a pull request. I hope that was clear, yeah.
I'm not sure if you mentioned, but how does it work if you have multiple microservices and say microservice A, that's where your changes are, but microservice B also made some changes and you want it to interconnect with each other? Yeah.
Yeah, that's actually where this excels. So it's configured. Let me see if I can go back to the slide, and maybe I can show that it's mirror. close this. Where's my browser? All right. So essentially, this comment is the configuration. So if you can see, for example, let's assume this front end is one microservice and this back end is another microservice. And I want my front end microservice on this branch to talk to a microservice on a different branch. And I can actually, let me go back to an existing environment and I will show that. I will probably not show that all the way, but this is essentially the workflow. So let's say I will come to this PR, I will click edit this comment, and I can set the backend branch to be, let's say, feature branch, right? And both for this, I mean, this is going to fail. There's no such branch. So then it will build the front end from this branch and the back end from this branch. So actually, let's get a real branch and we can maybe show this. Branches. Let's just grab this one. It's here. I'll just put this branch here. And then I'll just say update comment. And then it's going to start building those. If I look at the UI right now, you can see that the back end is going to be the patch 4, and the front end is going to be patch 6.
Yeah, so what happens if there are dependencies of like a branch of a branch, and then the initial branch, they've accepted it and merged it into default, but your dependencies might still be on the second branch, it might still be on the first branch and not yet on default. Although, yeah, technically, once it's in default, you should be pointing to default.
Yeah, so that's a very good question, and we kind of like address that. We say just bring in all your dependencies inside one environment. Like we don't need to be having like 5 different environments. Like just bring everything over there. Just like for example, in real world in GoodRx, like that the optional dependencies list is pretty large for us, and you can just select the things that you need, and then it'll deploy that environment specifically with those set of changes from those branches. But there are other ways to kind of like achieve that. You can add custom environment variables, essentially, which will point to the service that you want it to point to. But the general kind of like recommendation that we give our engineers is that just like put everything in one PR so that it's easier for you to know where your changes are altogether. And that feature that I showed on this, where it tracks remote branches, so then you might have a long-lived feature, so then you can check this box and all the changes that go to the branch that is specified, this will track those changes. So you will always have up-to-date environment for your large features, so to say. Yes?
The build that's happening right now, it says it was building. Is it that? What am I trying to say?
What is it actually
is
doing?
this mostly is this most of your CI, or is this secondary to your normal CI process?
So for building and deploying, we're using our CI, the same patterns that we use to deploy and build for production. So essentially, for example, in this ephemeral environment, you can test your Helm values. Like we have our own Helm chart with different configurations, stuff like that. Let's say there's some things you want to change. Let's say the readiness or liveness probes you got to update. You can test that in the ephemeral environment. So
yeah, I think I understand that part. You had said for one of the things, if you didn't want to like immediate live environment, you could have a pending environment until your checks pass. Those checks are coming from some other CI system?
Yeah. No, yes.
And does that mean that do you just use this build going forward, or do you build it twice, one in the normal CI and then one here?
That's a very good question. Sorry, I think I misunderstood your question. So we use the same build. Lifecycle has webhooks, kind of like workflow webhooks. So we can specify on each different condition. Let's say your deployment failed. Is there something you want to run? Is there something you want Lifecycle to do? Or your deployment succeeded? Then you can set it up to trigger the end-to-end test pipeline by, again, being able to pass those environment variables in a templated way. Let's say we're going to trigger an end-to-end test pipeline. We need to give it a base URL where the environment is deployed. So Lifecycle will also trigger those. And it's not going to build the second time. It's just going to say, okay, I got the environment, it's ready, it's deployed. I want you to run tests on this environment.
So the definition for the like container build, that is by convention that things from various repos like just have a standard Docker file and you know what to do, or does it leverage, like if I was developing something within this ecosystem and I wanted to do something slightly different for my build, am I able to do that, or am I sort of beholden to what lifecycle builds look like?
You can do whatever you can do in a Docker file. So in Lifecycle YAML, you just specify the Docker file path. Let me see. I think this is, so let's go back. So this is the Docker file for our front-end app, right? So this is the plain Next.js app. And if you look at the Lifecycle YAML, if I can find it, and we're just setting the Docker file, we're referencing the Docker file, which one it should use to build, and then it'll just set that as the Docker file path in the CI, underlying CI, and then it'll just build and push to whatever registry it's configured to push.
More questions?
Do you still only support CodeFresh, or have you added in support for GitHub Actions or anything else yet?
Well, thank you for that question. We do plan to support other CIs, but at this point, we only support CodeFresh. We actually have plans on having a built-in CI within kind of like the CI functions that Lifecycle needs, building, running tests, and stuff like that. But before we open source the code, it will have GitHub Action support. So, and yeah, if there are no more questions. Yeah.
Hi, Nick.
Hey.
First-time caller, long-time listener. What language is this written in?
So Lifecycle, all right. Let's go there. Yeah. It's Lifecycle itself is a Next.js app. It's written in JavaScript, TypeScript, and yeah, short answer.
Is that the language when it is open sourced? It will be
Yes.
that stack too?
Yes, but yes. We're going to have more info around this after we open source it, like kind of like what is the short-term, long-term plan or future for this project. But what you saw is what we're trying to put out, essentially. And I want to take a moment and thank all the people that contributed to Lifecycle over the years. One of them is sitting right there, Wes. Thank you so much. Round of applause, please, for Wes. Thank you. Kyle Alwyn, which I hope he's watching. Thanks, Kyle. Andy Chan over there, one for Andy. And we have Jeff, Nick, Vignesh sitting over there. So you guys are amazing. This was truly a team effort at GoodRx. And we're, specifically me, I'm very passionate about this. So if you want to chat about it, catch me in the hallway. We can talk about it. And thank you so much for the great questions. And I hope this was interesting.